Hi, I'm Henry Brill, and this is video V1, polar coordinates. So I'm going to be doing questions 5 and 9 from homework 1.4. Uh, First thing I want to look at is question 5. I'm going to use Desmos to just first look at the graph. So I have question 5 right here. Find the area inside one leaf of this rose, and that's the equation. So I went ahead and graphed this, and we can see there's three leaves, petals or whatever, and we want to find the area inside one of them. So to find the bounds for this equation, uh, we know that we want to find the area of one of these sections. So when r equals 0, the first two times r equals 0 will be kind of like the bounds for this first time, for this first petal. So we want to set this is the right equation. We want to set the 5 sine 3 theta equal to 0, and we want to solve for that. So we can do that right now. So we have 0 equals, sorry, that's 0. Handwriting's not great on this. 5 sine 3 theta and now we can divide both sides by 5. 5 over 0 is 0. Or sorry, 0 over 5 is 0. So now we could inverse sine 0. So inverse sine of 0 equals 3 theta. And if we look or think back to the unit circle, inverse sine of 0 is equal to the first two times sine is equal to 0 would be at angle of 0 radians, and then sine will once again be 0, or the y coordinate will once again be 0 of the unit circle at pi. So first two instances are 0 and pi. So now we have 0 and pi equals 3 theta. Sorry, you might hear my dog. But these are our two answers, or our bounds. And now one last step to actually find them. We divide both bounds by 3. 0 over 3 is 0, so one of our bounds is 0. And then our second one is pi over 3. So yeah, 0 and pi over 3. So now we can use our formula for area. A equals 1/2 integral from b to a. We know we just found our bounds. Pi over 3, and so 0 to pi over 3. And then we have our equation, which is 5 sine 3 theta. Yeah, 5 sine 3 theta. Then we square this whole thing, and we integrate in terms of theta. So now we could plug this integral in the Desmos, and which we do right here, and we get our answer. So area equals, it was 6.54 units squared for one petal. .54 units squared. All right, now for question 9. Find the arc length of the polar curve described by that. So first step again, I'm going to graph this. So get rid of this now. Okay, r of theta, what was it, equals 5 plus 5 cosine theta. Okay, so we have a cardioid this time. And we want to go back to the question. We want to find the arc length of the polar curve described by that. So this time for the bounds, we see that it is the first time it is r is equal to 0, and then the or sorry, not 0. No, r will not equal 0. Sorry. First time x is equal to 0, and then the goes around once, and then the third time. So r is not equal to 0, r is equal to 10. So what we could do here is set r equal to 10, our equation equal to 10, and we can see the first two times where that will happen. We can see the angles at which the first two times that will happen, and that's how we can get our bounds. So I will do that right now. So we have 10 equals 5 plus 5 cosine theta. So now if we subtract 5 from both sides, we'll get 5 equals 5 cosine theta. All right, now we can divide both sides by 5, which will get us 1 equals cosine theta. And now we're going to have to inverse cosine theta. Or sorry, not inverse cosine. Let me backtrack here. We have to do inverse cosine of 1. Equals theta. And inverse cosine of 1 is, so if we think about the unit circle again, we have first time, we'll have 1 in the x coordinate is going to be when there's no angle. And then the next time we have 1 as our x coordinate, positive 1 as our x coordinate, would be at the angle 2 pi. So our, let me solve this. So theta equals excuse me, 0, 2 pi. So those are our bounds here. Okay, now we gotta do now that we know the bounds, we have to actually integrate. So the formula for arc length is a little bit different. So we go from the integral of 2 pi to 0, because those are our bounds we discussed earlier, and we still have to do a little bit more. So we do the square root of dr d theta quantity squared plus r squared d theta. So we have r, because r is just, our equation. We know r is 5 plus 5 cosine theta. But we need to find drd theta. So to do this, we could not multiply. We could take the derivative of both sides in terms of theta, which is what we'll do. So dr over d theta equals, now we can break this apart. So we got derivative of 5 times theta, that's just 0 because it's a constant. So 0 plus, and then the derivative of 5 cosine theta. So that's just 5 times, and the derivative of cosine is negative sine, so sine. 5 times negative sine theta. So dr d theta is just negative 5 sine theta. All right, so now we can plug that back into our equation right here. So now we could do this. Boom. Okay, so now we know S equals, and we have our bounds from earlier, 2 pi 0 to 2 pi square root. And it is dr d theta squared, which is negative 5 sine theta squared plus r squared, and we know r is just 5 plus 5 cosine theta. And then we square that again. We square this. And then we are doing this on the square root. And then we do this in terms of theta. Integrate that in terms of theta. So this should get us our answer. Now we could use Desmos to evaluate this. So let me go over here. All right, so we have from 0 to 2 pi. So square root of negative 5. Negative 5 sine theta squared plus 5 that looks right. Now we can evaluate this if I put the extra parenthesis in there. And we can see that this integral comes out to equal 40. So let me, S equals 40 units squared. Yeah, so that's our answer, 40 units squared. Thank you for watching.